For this activity 2, we are going to talk about the inverter gate, and we are here to demonstrate and simulate the basic function of the inverter and its application. The inverter integrated circuit is one of the simplest digital logic gates in terms of its function. This gate simply complements the logic input signal. The symbol of the gate comprises of a triangle with a small circle by the tip. The input side is from the base of the triangle, and the output side is from the tip with the circle. The truth table easily describes the inverter. When the input is 0, the output is 1. When the input is 1, the output is 0. It basically inverts the input and turns it into the opposite form. Next, let us talk about the 74 LSO4 integrated circuit with its 14 terminals. One terminal is for the power input and the other opposite end is the ground terminal. The remaining 12 terminals make up the 6 inverters provided by this integrated circuit. Now, our goal for this activity is to figure out what's the outcome for this LED and LSO4 configuration. Analytically, we can try to figure out the output with the given input of 0. So at L1, there is 0 input, thus the output is also 0. At L2, since it is inverted once from 0, the output is 1. At L3, it is inverted twice from 0. 0 inverted to 1 and inverting it again from 1, making it 0 once again. L4 has the same configuration as L3, thus it also has an output of 0. Lastly, at L5, it is inverted thrice, or the output of L4 is inverted, so we can say that its output is 1. Here is the truth table when the initial input is 0. And here is the truth table when the input is 1. It is simply a complement or the opposite of when the input is 0. So let's start! The materials needed for this activity are the breadboard, a power supply, 5 pieces of resistors, specifically 3.9 kilo ohms resistor, 5 pieces of red LEDs or LEDs, and most importantly, the 74 LSO4 integrated circuit. We also need the push button and the connecting wires or jumper wires. Before we start with the hands-on proper, we can simulate the configuration using Tinkercad for easier building of the hands-on circuit. After multiple troubleshooting, we now have the working circuit which coincides with our analytical solution. Before we begin, let's check if the components are working. Here we are checking the LEDs, and the other one we are checking the resistors. With safety precautions in mind, now we can start.
Saw you in the red dress. I can't seem to understand how you got all that finesse. Still been running in circles inside my head.
As you can see, the output of our hands-on circuit coincides with our Tinkercad simulation and also coincides with our analytical solution from before. This activity successfully demonstrated the basic operation of the inverter gate using the 74 LSO4 integrated circuit. By observing the LED outputs, we confirm that the inverter flips the input logic from a low input 0, which results in a high output 1 and vice versa. This fundamental logic operation is crucial for building more complex digital circuits with real-world applications in computing and signal processing. Further explanation could involve more combining multiple gates to create more advanced logic functions. I hope you learned something. Thank you for watching.